everyone, welcome back to Let's Unbound. So we are in 10th episode of this particular series, and in this particular episode, right, so I have combined two subunits together. So 2.10 and 2.11. So inverse of exponential functions and logarithmic functions. Inverse of exponential is logarithmic, and we will learn the basics and the important key features of logarithmic functions. So let's get into this video. What inverse of exponential functions? Inverse of exponential functions are logarithmic functions. So that's simple. Like how squaring the inverse is square rooting it, right? Dividing, multiplying. So something like in functions, exponential has an inverse which is log, and vice versa. Log inverse is exponential. So actually, exponential means it will be a rapid growth or a decay. Correct? What this logarithm will do? It will reverse the process. Maybe very slow or there will be not a rapid growth. Maybe this it will slow down. There will be a slow down increase. And if y equal to a power x is exponential, then its inverse will look like this. So log a, y, the output is input here, input is output here, and a power, like exponent changed to log with the same base. And yes, we have a condition for this log, the base a should be positive, but it should not be 1. Okay, so this means swapping the roles of x and y, yes. So inverse means if your original function have xy, your inverse function will have yx. That's it. If you do it at every point, you will get the inverse function. Now, inverse of exponential is log. Let's do it graphically. Inverse is reflection along y equal to x line. Okay, so let me draw y equal to x line. 1, 1, 2, 2, 3, 3, 4, 4, like this. Because it should be perfect, otherwise reflection will completely affect it. So this is my line I'm going to reflect it, or you can reflect each point. Either you can just go, like if it's, this is 0, 1, x is 0, y is 1. So 0, 1, you will write it, swap it, 1, 0, this point. And I can see this point, 1, 2. Now I will plot 2, 1. Let me go to this point, it's 2, 4. I will plot 4, 2. And do for the below also. It's almost very closer to -5. So it will be closer to like 0, -5. Sorry, -5, 0. Here I will switch it to 0, -5. X is 0, y is -5. So your graph will closely go through this. This is my sketch. Okay. It should be a curve like this. Wait, what? It should cross it, right? So it should go like this, and this. So this is exponential, this is log after regression. Okay. Now, logarithmic functions. Exponential functions grows rapidly for x greater than 0 and will decay for x less than 0. Logarithmic function will increase slowly. Okay, it will increase but slow. And only exist for x greater than 0. The domain is here important. Your input cannot be 0 or negative. And this is what we did. 2 power x is the blue curve. The green one is log 2x. Now, let's go for the key features of logarithmic functions. This is a simple log graph. X-intercept, yes, that is, it crosses at 0, 1, right? Y-intercept, it never crosses y-axis. So you can write none or not applicable, something like that. Asymptote, the graph is approaching a line, which is the y-axis. Or you can just say y-axis equation is x is equal to 0. Increasing, yes, keep your finger and it moves up and up when you move right. So it's always increasing. Decreasing, it's never decrease. Okay, so never decrease. Domain, we can see the graph starts after 0. It's not even starting at 0. After 0 until infinity. So x greater than 0 or in inequality direction 0 to infinity. Range, full y value it takes from negative infinity to positive infinity. So minus infinity to infinity. And in increasing case, you can mention it's increasing throughout, but it's better to write x is 0 to infinity, 0 not infinity. Okay, so that's it. And now logarithmic function, again, this time it's the b had been changed. So if your base is between 0 and 1, you will have something like this graph. The previous one is b greater than 1. Now what does x-intercept say? X is 1, y is 0. What is y-intercept? None. It seems like it crosses at 5, but it's not. Okay, so none. Asymptote, your y-axis, so vertical asymptote, and x is equal to 0. Increasing, never increase. It's a decrease throughout, so it's always decreasing. And you can mention it's negative 0 to infinity, it's decreasing throughout. Domain, 0 to infinity. Range, minus infinity to infinity. Got it? Now, let's move on to next. Logarithmic transformation. So simple log function will look like this, log bx. I multiplied a, I subtract h, horizontal translation, then multiplied c, k. So it's very like exactly same how we did for other functions, quadratics, polynomials, right? So if your a is greater than 1, it will give you a stretch, vertical stretch. If it's between 0 and 1, it's a compression. Reflection means when your a is negative, so for negative, it's a reflection and also stretch or compression based on a value. Then horizontal stretch, when you multiply something inside with x. Okay, so log b cx means let's see greater than 1 compression. Scale factor also you should reverse. This word also will reverse. Greater than means we will think okay we are stretching, but not in the case of horizontal. And when it's between 0 and 1, it's a horizontal stretch by factor 1/3 by c. Here, horizontal shift, replace x with x minus h. If your h is positive, like x minus 2, 2 right. Okay. If it's x plus 2, 2 left. We should be careful here. Vertical shift, add k. So adding k here, if it's k greater than 0, we are moving up. K less than 0, we are moving down. Now keynotes, this vertical asymptote will be originally the y-axis. After transformation, like depends on what I add inside horizontal, the vertical asymptote will shift, and hence the domain also will shift. And range is all real numbers every time. Right. Let's go for questions. Find the domain, range, asymptotes, and end behavior of the function. So domain, how we should do here is input of logarithm should be greater than 0. That's it. 6 minus x greater than 0. Minus x greater than minus 6. When you divide by negative, it's okay. You can do it on both sides, but inequality will change. X less than 6. In internal addition, minus infinity to 6. And 6 not included. This is domain. And coming to range. Range is always all real numbers. Or you can check your 6 minus x is greater than 0. When you apply log 2 on both sides, that also greater than 0. When you multiply by 3 also, it will be greater than 0. So it will never become positive or like negative or something. So ranges from okay, now coming to range. Range is always minus infinity to plus infinity. Whatever the log graph, it's all real numbers will be the range. Now asymptotes. Asymptotes, like where you have a domain restriction, right? It will be a number someplace. That is your asymptote. So x is equal to 6 is the vertical asymptote. And end behavior. So the log graph will go something like this. Okay. So it's not always this limit extends to minus infinity plus. So let's see this. Let's see how the graph will be. Okay, I know it says x is less than 6. So this is your 6. Your graph will be somewhere in this part. Okay. Now let's see log 6 minus x, like when you give 0 or something, it's 6. Or when you give 5, it's 0. Right? So 3 log 2. 6 minus 5 equal to 3 log to 1. Log with anyways 1 is 0. Okay, so it's when x is 5, y is 0. Is the x-intercept. Now, so it will approach like this, maybe, but let's check whether this is correct or not. Limit extends to negative infinity. Let's see. Negative infinity to 6. Negative infinity, we check. 3 log to 6x, 6 minus x. Okay. When it goes to negative infinity, it will become a bigger number and your graph will approach positive infinity. Okay, yes, it's up. Positive infinity. So limit extends to negative infinity is infinity. This thing, log 2 6 minus x is positive infinity. Then you should not do limit extends to positive infinity. Instead, you should do whatever your vertical is plus 6, 3 log to 6 minus x, which is, it goes down when it approaches 6, so negative infinity. This is the end behavior. And question number 2, write a logarithmic function with the given information. So, limit extends to positive infinity. Right side, it goes to negative infinity. Okay, that is this right side. And to the right side of 4, it goes to plus infinity. This is your 4. It goes to plus infinity. How can I do this? Is not a logarithmic structure. So let's see. X is 4 means this condition will come from the domain. So log some base b, you can, like, your vertical asymptote will be from this factor. So you can use x minus 4. Okay, so x minus 4 greater than 0 and I will get x greater than 4. You can't use 4 minus x because if you choose 4 minus x greater than 0, x is less than 4. But we are doing right side of the 4. So x is x minus 4 will suit. And what is the base? When your b is greater than 1, you will have something like this. When your b is between 0 and 1, you will have something like this. Okay. So which goes to minus infinity? When x tends to infinity, y goes to minus infinity is this case. So your b should be 0 to 1. So this is not possible. Even x is equal to 4, you can draw, but if x is equal to 4, it should go to positive infinity. It's complete opposite. So we pick the graph. And b should be any base between 0 and 1 you can pick. So I'm choosing log 0.003 x minus. That's it. This is one of the example. By changing the relevant base, you can. Now, question number 3. The graph of function is transformed to obtain the function g of x like this. Negative 3 log 2, x minus 2 plus 4. Describe the sequence of transformations applied. Sketch or describe the graph of f g of x including. So this is OG function log 2x. Okay. So we know that it's great. It works on greater than 0 only, like x greater than 0, and it goes from minus infinity to plus infinity. It crosses at 0, comma b, all this. Now, let's take this and work on the transformation tools first. And then we will go to part B. Okay, g of x is negative 3 log 2, x minus 2 equal. Okay, actually transformation, right? So log 2x is what we all have. X minus 2 means what? It's a horizontal shift, correct? So we can say it's a horizontal shift. And which direction? All we can see. So this x minus 2 says horizontal shift. Right by 2 units. Next. Multiplying 3 and the negative. So this negative 3 log 2x minus 2. After this, what we have? Reflection over what axis? Like maybe stretch and reflection. So vertical reflection and there is a stretch. Vertical reflection and stretch, right? Because the number is greater than 1, so stretch by factor 3. Next, last one, it's adding 4. That will give us negative 3 log 2 x minus 2 plus 4. It's a vertical thing because we are outside. So vertical shift by 4 units up. So these are sequence of transformations. And now we need to find asymptote, domain, range, x-intercept. Okay, here for the transformed function, what is asymptote? Which line the graph is approaching? So it approaches the x-axis, right? So x-axis means you will put, oh, it's not a horizontal, it will cross, right? So vertical asymptote we have, and maybe here we can see it will approach like this. So at x is equal to 2. Okay. Then domain for x greater than, it's not 0. When you carefully watch this, it's working on between, okay, if we take this as 0, okay, it should be 0, 2, 4, 6, 8, 10, 12. So domain should be greater than 2, that vertical asymptote. So domain and asymptote. Asymptote will affect the domain, and range is minus infinity plus infinity. X-intercept as it crosses somewhere here. So how can we find it exactly? Yes, we can do it algebraically. You write the function g of x is equal to 0. So you got 0 equal to negative 3 log 2 x minus 2 plus 4. I'm subtracting 4 on both sides. Negative 4 equal to negative 3 log 2 x minus 2. So dividing by 4 by 3 is log 2 x minus 2. So now 2 power 4/3. If you raise to the 2 power, 2 and log 2 will get cancelled, x minus 2. And you can continue this, x is equal to 2 power 4/3 plus 2. And when you simplify, you will get something like 4.52 approximately. This is x-intercept. Right. And that's the wrap with the bonus question now. A scientist is studying a radioactive substance whose mass is in grams at time t days is given by the function. Find inverse. Yes, we know it's exponential. So to find the inverse, use your inverse to determine how many days it will take for the mass to decay. Round your answer to 2 decimal places. And yes, good work for today. And we are meeting in next video very soon. Until then, keep learning, keep practicing. Don't forget to join Let's and Bump student community. You can scan the QR code here.